Hi everyone, and welcome to our tutorial or how-to video of how to machine this brake lever for Cal Baptist University's Formula SAE car team. So as you can see, I've imported the part. Our steps are going to be pretty standard. Okay, I know many of you look at this and go, oh no, this is so different. It's not. It's still very similar to all of our titans of CNC and things like that. We're going to start out exactly the same. So first thing we're going to do, we're going to go to levels and we're going to change where it says brake pedal, and we're going to call that, we can call it part or model, anything like that works as long as you remember what's going on. Level 2 will be stock. Okay, just like always. Okay, and then what we're going to do is we're going to make a wire frame around it that's going to represent our metal. Now there's going to be some issues because maybe you don't know how thick this thing is. Okay. I do have it open in SOLIDWORKS, so I can do some measuring if needed. So with our two levels up, the first thing we're going to do is we're going to go into wireframe. We're going to do a bounding box. Okay, I'm going to do it from the top, just like I always do it after I select my part, of course. I'm going to add stock from the top. Okay, now, if you look at this, it's a horrible shape. Okay, that is a big chunk of metal and we'd be wasting a lot. So what I'm going to do here is I'm going to do the orientation. I'm going to manually do it. And then I'm going to click this button. It doesn't really matter what I pick. What I want is one of my axes to be parallel to this long line right here. So it's kind of easy just to pick the center of a circle. Okay, it doesn't really matter which, as long as you're somewhere you can see it pretty well. Okay, like so. All right, then what I'm going to do is I'm going to angle it so that it's parallel. If I remember right, it comes out to be kind of like -140. Okay, that's pretty parallel. I can always adjust it. Now, my axes are not set up correctly. My X and Y are not in the right direction. I want my Z pointed up, so I'm going to move that guy. Looks like -90. Or maybe +90. There we go. It's a little better. Okay. Let's see. I need my X to be going 90 degrees here. Okay. Now, when you look at it, all right, that line may not be perfectly right down there, but it's definitely going to be better. If I want to move it, I can try to get it pretty darn close. That's not it. That's not it. So I think I'll just leave it. Okay. That will orientate me pretty well. Okay. So I'm going to hit enter when I'm done. Now, look at my block. I don't have a bunch of wasted stuff. Looks like I'm pretty parallel. If you were not down here, if it wasn't perfectly parallel, hey, don't freak out. It's no big deal. Now we're going to stick with our standard, add material. On the X, I just click over here. I'm going to plus 0.1. Okay, I'm adding 0.1 to it. For my Y, I'm same story, plus 0.1. For my Z, okay, this is kind of weird because I go plus 0.25. Okay, but remember, I shaved 20 thousandths off of it at the beginning. So after I add the 0.25, I'm going to say minus 0.020, hit enter. All right, because I'm going to shave 20 thousandths off. All right, so let's see here. When we look at these guys, they're kind of awkward numbers. I'll be honest with you. That 10.31589, that's a horrible number. 2.4 is pretty easy to work with. I'm just going to change that to 2.5. Okay, it's a little bit bigger. 10.31, so, all right, so I can tell you when you look at the decimals, 0.25 is a quarter inch. So maybe we go another 1/16, so we'll be 3/16 of an inch. So that's like 10.375 if I remember right. Something like that. Or maybe we'll just do 10.375. Let's see if I like that. Okay. Brain fart, let's see. 3 divided by 16. 0.1875, okay. And then plus 0.25. So that's what I would be. 10.4375. That's just getting to be an ugly number. Let's just make this 10.5. Okay. Much easier number to cut. 2.5 is a nice number. 0.863 is kind of I can tell you 0.875 is a nice number because that's 7/8 of an inch. Yeah, 7 divided by 8. Yeah. All right. I don't like any of these numbers. let's do 0.875. Okay, so that's what we're looking at. We load a part on, we start out with something that's 20 thousandths bigger. Maybe our easiest thing to do is 1 inch, because we do have 1 inch material around. Okay, so hear me out here. We're going to grab a block that's 1 inch thick. Okay, that's what we start out with. Then we're going to shave minus 0.020 off of it. Okay, and that leaves us with that. That's an easy thing for me to find. So I'll need to find a block that's 10.5 inches long. Obviously, I can cut that. 2.5 inches wide and 1 inch thick to start. So that's a pretty reasonable number. Okay, those are things you got to think about when I'm not telling you everything. Solid, make sure it's solid. Hit OK. There's my block. Now, I have not saved yet. It's probably a good idea to hit save. Okay, you can see I got a bunch of them on there, but let's not worry about it. I'm going to call this one break video, and I'm going to overwrite it. Okay, so there we go. We got some stock, but what we don't have is the stock model. So when we go to Toolpath, there's nothing there, right? So we're going to go to Machine. I'm going to select Mill. If you only have default, that's fine. If we loaded the Haas 3-axis mill, you want to pick that one, but we'll pick default. Remember, you need to pick it based on what machine you're going to be using. And MasterCAM crashes. So I'll pause while it restarts. And that, ladies and gentlemen, is why we save and save often. So let's try this one more time. Go up here to my machine, hit mill, default mill, doesn't crash, yay. Okay, so we'll keep moving on. Good time to save just because I'm getting nervous with MasterCAM. All right, so you guys know the deal. We do the stock model. We hit stock. Okay, I'm going to call it stock. Okay, I'm unclicking that stock plane. I'm going to base it on my model. I'm going to select my model. Just triple click this guy. Boom, hit an end. Hit OK. There it is. I now have a stock model. Now, let's talk about tools. So ideally, I don't want to change out everything on one of our Haas milling machines to make this guy. Let's take a look at the part. If you look in here, there's nothing that weird, so we're going to use our face mill that we always use. I can kind of use any end mill to go around the outside to contour it. It doesn't even matter with that. I can use a big old huge one. What will matter is these slots. So let's take a look at how big these slots are. So if I hit measure and I hit, that guy, it gives me a radius of 0.383. It's a weird number, 0.383 times 2. Okay, so I can use up to a 3/4 inch end mill on this, okay? Because that's a radius. I times it by 2 and I get that. That's diameter. So that would be my largest tool I can use. Now, I do not have a 3/4 inch end mill loaded up all the time. Could I for this? Yes. Do I want to? No, because I don't want to deal with messing with it. All right, what else do we got here to worry about? We're going to have to worry about circles, okay? These, we want to drill these. Okay, so what I'm going to do is I'm going to bring up microphones because I didn't like the way this microphone sounds. All right, this is our Haas toolset one. 2-inch face mill, sure, we'll use that. In fact, you know what I think I'll probably do? I'm going to do this. I am going to copy this guy. I'm going to make a new tab for it. And I'm going to put it right here. And I'm going to put it CBU, oops, I like all caps, CBU toolset brake pedal arm. All right, cool. All right, so we know I'm going to use my face mill. Am I going to use my 3/8 inch end mill? I don't think so. I mean, where would I use it on this thing? So I don't even need that. I'm going to hit delete because I don't necessarily need that. It might give me an empty space for later. Okay, that 1/2 inch end mill, that's the one I'm going to use going around it. Okay, I can do it in here. I can do it out there. Would it be nice to have a bigger one? Sure. But I don't think I'm going to bother using it. Now, chamfer mill, I am going to have to chamfer. Okay, there's chamfers around the edge. It's larger than normal, but I can do it with our chamfer mill. I don't need this drill, so I'm going to take this guy out. I don't need this tap. I definitely don't need a 1/16 end mill. I don't need a 1/8 inch ball end mill. We use that for engraving. And I don't need this variable guy. All right. So I have lots of room here to add stuff. Now, most of these, like the ones I deleted, I don't really want to mess with. In fact, if you look at our normal tools, these last 3, 7, 8, and 9, these are the ones I don't mind taking out because we don't use those a lot. So just FYI. So I'm going to try to use 7, 8, and 9 here if possible. So let's look what I need. I need a drill for this. Why is it in 2 halves? That's very annoying. All right, so it has a radius of 0.157. 0.157 times 2. So I need to find a drill bit that is 0.314. I don't even know if that exists. So we got to bring up a chart and see if I can find it. All right, so I did locate where I have my drill chart saved. So what size drill am I looking for? 0.314. Let's take a look at my chart. Okay, I will upload this for you guys. So drills, regular drills are available in fractions, decimals, / numbers. So like this one says a 76 equals 0.020. They're also available in letters. That will really screw you up. F, G, H. Okay, they're all available in those 3 sizes. What we're looking for is 0.314. Now, as you can see, we have a problem. They chose a hole with a weird size. They have 316, 3125, so that basically is 0.313. Maybe they're shooting for a 5/16. Now, could I drop in a end mill, a small end mill? It would have to be smaller than 0.314, so I could do a 1/4 inch end mill and run it around there and make it the right size? Yeah, probably. But good news is I emailed them and they said 5/16 is fine. So 5/16. Now that means in our tools, wherever I save those tools, no, not chart, tools. All right, right here. We're going to call drill bit, and it's going to be 5/16 inches. Okay. I can tell you, we can go pretty fast with that. We're going to go 4,500 RPM. We're going to do a feed rate of 25, plunge rate of 25. And on a drill, feed and plunge is the same. Okay. Next size I have in there. Let's take a look around. I got this other circle right here. Boom. 0.375. Oh, they picked a nice size. So right here, you go to your chart, 375. There it is. It's a 3/8 drill. All right, we'll load that guy up here. Again, drill bit. It's going to be 3/8 inches. It's bigger. I'm going to go a little slower. I'll go 4,000 RPM. I can still feed at about the same rate. Number 9. Okay, there is a number 9, trust me. Okay, so we got the holes, but what we have here is this weird fillet. Okay, right here that goes around that sucker. We are going to need to deal with that. So let's see if we can find where they made it. Okay, it's right here, fillet 1. Let's see what the feature says. So it is a 1/8 inch fillet. Okay, 1/8 inch, that's 0.125. That means to make that, I'm going to need a 1/4 inch ball end mill. Okay, so right here, I will put ball end mill, and it's going to be 1/4 inch diameter, and I can haul butt with that one, 5,000 RPM. I'm not going to go around it real fast. I'm going to do like 35. Plunge rate of 50 is fine. Very conservative, but this will all work. Okay, so I don't think I need anything else. Okay, not that I can see yet. Now, eventually, we're going to have to deal with this hole on the side here, but that's a different step, so we're not going to worry about that. Okay, so let's get back into MasterCAM. All right, now let's get my tool manager up. Okay, and I'm going to open my Haas toolset or Titan toolset 1, which I thought I had a shortcut to that. Bummer. Oh, wait, there it was. Okay, Titan tool library 1. Okay, so remember, I don't need everything. I need this guy, I need this guy, I need this guy. And what else did I need? I think that was it. I don't need this drill. I don't need a tap. I don't need that flat end mill. So that's all I need for now. I'm going to hit up so I have access to those. Hit OK. All right, so I have some tools to work with now. Haven't hit save for a while, so let's hit save. Okay. We also need to do our origin. Okay, so let's hit this guy right there. Well, hold on. Let me back out of it. I want to make sure it's facing. Ooh, that's an ugly way. Okay. All right. So again, make a new plane. We're going to snap it right on that corner like we always do. Okay, but man, is this thing crooked. So again, we got to do something here. We got to line it up so it's 140 degrees there. Cool deal. My X, Y, and Z are totally wrong. I need my Z facing up, so that'll be -90. Oops, how about 90? Okay, I got to get this guy another 90. All right, so that looks more like it. We know it's G54. That's our first Deal. Now, what do? Remember, we move it over 50 and 50 thousandths. So I click on here. I'm going to go 0.050. And then I'm going to click here. I'm going to go negative 0.050. This is just like you do on all the Titans of CNC stuff. Hit OK and hope it doesn't move. All right, let me edit it again. You guys have this problem. Hopefully MasterCAM 24 doesn't have this problem. Okay, we're looking good. All right, so we got that. Now let's do some milling. Let's actually make some chips. We're gonna face off just like always. I'm gonna pick this top face here, hit OK. My tool is gonna be tool number 1, my 2-inch face mill. Make a note. Face off part 60 and 4500. So here's my settings in case yours did not save correctly. My cut parameters, I'll just do my zigzag like always. I'm going to leave no stock on the floors. Okay. These are, the shape of my zigzags, which you can edit, but honestly for us, most of the time, these are just fine. And we're going to move between cuts with high speed loops. No depth of cuts is required. Linking parameters, make sure all of these are set to absolute. Okay, I'm going to change this guy to 0.1. Top of stock is 0, depth is 0. We're just going to shave off, and remember, it's 1 inch tall. We're shaving some off. Let's see. Nope, I got to change all these to G54. Copy that over. Okay, coolant should be set to flood on, and when I hit OK, I get shave it off. Let's hit save. Now I don't want to have to change my settings for my planes every time, so I'm going to come in here. I'm going to click down here, and that will move all of these. These are my working coordinate systems. All right, so now we've shaved it off. It's now the proper height. You guys know the next step. We're going to opti-rough. Okay, so let's turn some things off. Okay, now we're going to opti-rough. Opti-rough. Okay, we're going to leave 5 thousandths on. Honestly, you guys, we could probably get away with doing it all at once, but we want to do it right. Okay? So we're going to opti-rough this guy, leaving 5 thousandths on. Tool path control. Remember, this tells me it's going to tell the tool where it can go. I'm going to click this guy, and then I'm going to hit shift and click here. It doesn't go all the way around. That's okay. I'm going to hit next to keep hitting next until it comes full circle. I'm going to hit OK. I'm going to allow it to go outside of what I just picked by 1 inch. Okay. If I let it go 1/2 inch, 2 inches, whatever, 1 inch seems to work good for us. Tool, well, all right, 1/2 inch flat end mill. Okay, and I always like to put opti-rough part. Okay, it's going 35 inches per minute at 4,000 RPM, so that's pretty good. Now, it calculates movements and cutting based on material, and it's from one other operation, and that operation is when we made the stock model. Cut parameters, all right, this is what we don't know. Step down, how deep can we go? All right, let's take a look here. I guess I'll look at it from there. All right, how thick is this sucker? Measure, I'm gonna measure from the top here to here. All right, so it looks like we're looking at 0.633. Okay, 633. Now, we usually go 10 thousandths deeper, so I'm gonna set it at 0.643. Okay, 0.643. So, step down, 0.643. Okay, I need to have step up turned on. It allows it to jump back up and go down these holes. Now remember, my step over distance, that's, as it's making its little cuts, how far does it move after each cut? 25% is very conservative. Let's go up to 40%. That way it's not going to take quite as long. Okay, remember this 0.643 number. Okay, steep, shallow, we're going to tell it how deep to go. Turn all this on. Maximum depth, negative 0.643. Okay, linking parameters, I set this to clearance, or its clearance plane is 0.2 above the top of it. That's plenty. Plane should be G54, and coolant should be flood on. All right, let's take a look. All right, there we go. So we got a lot of material we're moving. I'm gonna hit save because I don't trust things. Okay, so that will I'll get us pretty close. Okay, now we just got to go back and clean it up like you guys are used to. So we're going to do contours. All right, contour. And your order doesn't matter that much here, but I'm going to start on the outside first because I like starting on the outside. Okay, if you heard that noise, that was the microphone falling. That was the reason I was looking for new microphones. Or at least a microphone stand. All right, we're back going. All right, so I'm going to hit next. Okay, now I'm going around there. Hit OK. My tool, it's going to be that 1/2 inch flat end mill. Now, there's not a lot left. Okay, we only have 5 thousandths left. Guys, I'm going to haul butt. I'm going to go like 60 inches per minute. Okay, we'll say contour outside shape. That works good. Make sure rapid retract is turned on. Cut parameters. We always set this to where. That way we can make adjustments at the machine. We don't need depth of cuts. We're just going to go all the way down. We'll go ahead and turn lead in, lead out. It's not that important because there's not a lot of material left. So we'll have just little tiny curves as it approaches. We don't need multi-passes. We don't need anything else. We just need to tell it how deep to go. Okay, again, we'll go with 0.2. That 0.25 would have been fine. 0.1, top of stock is 0. And how deep do we go? Remember that minus 0.463? Hold on, I forgot the number. 643, almost. Okay, planes are going to be set to G54, coolant, yeah, we need some coolant, turn that sucker on. All right, there we go. Okay, remember these little loops, this is your lead in, lead out. It curves in so it doesn't slam into the part. If we change that from 30 to a bigger percentage, the curve just gets bigger. All right, hit save. Now let's take a look. We got to do these slots. These slots are not cleaned up yet. Okay, so we're going to do another contour. Okay, and I'm going to pick this guy, hold down shift. Now it's going this direction, which is fine because we go counterclockwise inside. I'm going to hit end. I'm going to do this one, hold down shift, pick that guy. I'm going to hit end chain again, hold down shift, pick that guy, hit end chain again, and guess what? We're all done. All right, tool, we're going to stick with that 1/2 inch flat end mill. Again, we're going to go pretty fast because there's hardly anything left. And we will say, finish cut inside slots. That'll work. Okay, cut parameters, again, we're set to where. Lead in, lead out will be fine. We have enough room in here to do the lead in, lead out. Linking parameters, it should all be the same. It'll be minus 0.643, I think. Sorry, I keep forgetting that one. Okay. Planes should be G54. Coolant should be set to on. Hit OK. Let's take a look. Ooh, no. All right, I know what I did. Parameters. Linking parameters. Let's try negative 643. Ooh, looks much better. Actually, inside the holes. All right, hit save. So we have faced it, opti-roughed it, contoured the outside, contoured the inside. Now here's our problem. This surface right here, it's still 5 thousandths too thick. Okay, because we left some on when we did opti-rough. Now in opti-rough, let me just show you. Don't do this. Let me just show you. On our parameters, we could have changed it to leave 0 on the floor stock, and it would cut the top of this to the exact height. Probably would have been a good idea. But this way, you get to learn a new toolpath. So we're going to scroll down here. We're going to find area mill. All right. I'm going to use the automatic regions. Just trust me on this. Click this guy. I'm going to pick this whole face. Hit OK. And then I'm going to tell it, no, that's not it. Oh, from machining region strategy. If I say stay inside, it just tries to go in here and it doesn't go outside of the face. I want it to come from the outside. Hit OK. All right. We're going to stick with that 1/2 inch end mill. Now, again, there's hardly any left. Go 60 inches per minute. I'm going to say area mill flat part. Close enough. I'll know what's going on. I'm not worried about any stock settings. Cut parameters, I need to make sure all these are set to 0 because I don't want to leave anything on. Okay. My step over is going to be 45%. So that means I'm moving over 45% of a 1/2 inch, which is right there. I don't need depth of cuts. I don't need any of this stuff. I just need linking parameters. Everything should be set to absolute. 0.25, whatever, 0.1. Okay, now, if I don't know the depth, remember there's a trick. I'm going to hit the button. And then I need to pick something that is the depth I want to go. Literally, it's all this stuff. Anything along here would work. This guy would work. This guy would work. So I'll just click here. So you can see I'm not cutting a lot off. Okay. Planes, all set to G54. Coolant needs to be on. Hit OK. There we go. We get back and forth a bunch. Now, what I don't like is it's lifting a lot. You see how it cuts, lifts, comes over. I'm going to hit save. I'm going to see if there's a way to make that more efficient, because, man, it is not efficient. Let's see. Corner rounding, compensation, linking parameters. I think for area mill, I'm kind of stuck. Well, keep tool down. No. Corner rounding tip. Nope. Yeah, it looks like I'm kind of stuck doing that. So that will make it important that I have rapid retract turned on. I'm going to turn my plunge rate up to 100. It's plunging off the side of it. See this green over here? It plunges off the side. So that'll make things a little bit faster. Okay, I'm going to hit save again, just in case. Alrighty. So general shape is good. We do not have this curve here, and we don't have holes drilled, and we don't have chamfers. Now, typically we do a chamfer type drill so that our drill bit finds where it's supposed to go here. So that means we should probably go ahead and chamfer. All right. So let's find some chamfering. Let's see. Model chamfer. Here we go. All right. Let's pick our geometry. So remember, you pick the actual chamfer. I'm going to hit shift and see how this works. Oh, almost all the way. Not all the way. So I'm going to keep hitting next till it comes around. Okay. I'm going to hit end. I'm going to do the same thing here. Shift. Okay. It goes all the way that way. It is going the wrong way though. So I want to hit reverse. Okay. Hit end again. Do it here. Okay. Hit end again. And one more time, do it here. And now we're looking good. So we're going to do a lot of chamfering. All right. Tool, we're going to use our 1/4 inch chamfer mill. Now, normally we go really fast. And that is because we're only chamfering 0.1 of an inch. We're not on this guy. Let's take a look here. So if you look at these chamfers, let me turn off measure. Let's just find where they made it. Okay, chamfer revision. All right, cool. All right, chamfer is 50 thousandths at 45 degrees. Good number, nothing funky, but we're going to have to go a lot slower. In fact, I'm going to take that sucker down to 20. And I'm going to say, whoops, chamfer all edges. Okay. Cut parameters. All right, so I'm going to set it to where, but here's my deal. Typically, you want to offset out the bottom further than your what you're chamfering. So that 50, it's probably okay. It's probably okay. We'll take a look. We don't need to do depth of cuts. We'll do it in one chamfer, but we're just going to go slow. Lead in, lead out, we definitely want it turned on. Okay. And I'll just leave the radius at 100%. Why not? Linking parameters. All right. Feed plane, 0.2, 0.25. Those are all fine. And then coolant, we want turned on. And let's take a look at this guy. All right. What do we got here? Big curves. Okay, big curve happens. It looks like I'm even with the bottom because of that whole 50 thousandths. So I'm going to go back here to parameters. And I think it was cut parameters. Yeah. I'm going to take this up a little higher. Let's go 0.75 and see what happens. Okay, so now we're a little bit below the chamfer. That's good. You don't want to chamfer even with you don't want your tip to be even with the bottom. It's just going to produce some issues for you. Okay, I haven't hit save in a while, so let's save this sucker. All right, so we're looking good. Now the next thing we want to do is we want to use that chamfer drill to do some, or that chamfer to do some chamfer drilling. But here's the problem. We chamfer drill, one, because it helps guide the drill bit, and then two, it makes a nice chamfer on the holes. Well, these holes are not chamfered. So that's going to cause us some problems. You can't hit, most of the time we hit, where is it at? There's a chamfer drill somewhere. But we can't do that. We got to do a normal drill, okay? But we're going to do it with a chamfer tool. So hit drill. I'm going to do these guys separately. I'm going to do this guy. Okay. Hit OK. My tool. It's going to be my 1/4 inch chamfer mill. I can tell you do not go 60. Let's just go like 20. And we'll chamfer drill larger hole. That's fine. Rest of this I don't really need to worry about. Cut parameters, I'm just gonna call it drill. We don't need to do anything else, okay? Not worry about any of these. What I'm just gonna do is I just need a little dent, okay? I need a little dent to guide it, okay? So that retract of 0.5, that's a lot, okay? Top of stock is 0. How deep do I wanna go? All right, we know that the top of this boss is the 0, okay? So I'm not gonna go really deep. I'm just gonna go like 0.150. That will make a nice V that will help guide my drill bit. That's the only purpose of it right now. Planes are G54. Coolant is turned, well, it's now on. Okay, so there's that one. I'm gonna do it one more time here. Okay, drill right there, hit OK. Same tool, quarter-inch chamfer mill, going 20, and we'll say chamfer drill small hole. Okay, not worried about much else in here other than my linking parameters. Okay, 0.2. Okay, now, okay, how deep do I go? Well, I don't really know how deep that thing is, so here's what I'm gonna do. I'm gonna hit depth. I'm gonna select this circle. It gives me that number, okay? And then I'm gonna go negative. That is the top of that surface. So I'm gonna go on a negative 0.150, hit enter, it does the math for me. That's how deep we're gonna chamfer drill. Planes are G54. Coolant is on, hit OK, boom, we chamfer drill that little guy. All right, hit save. We're getting close, ladies and gentlemen. We are getting close. Now we gotta drill, and when we drill, we gotta make some tools. Okay, so I'm gonna hit drill. I'm gonna pick. Now these are 2 different sizes, so I can't do them at the same time. I'm gonna pick this guy. Doesn't really matter what order I go in. Hit OK. Now I do not have a tool for this. This is the smaller one. And it was a 5/16 drill bit. Okay, let's take a look. So I'm gonna right click here. I'm gonna create tool. Okay, it is a drill right here. You might have to scroll down. It is a drill. Hit next. Okay, standard sizes. This is gonna annoy you. There's so many here. So you're gonna scroll down to 5/16. If you remember, it's 0.3 something. So you gotta scroll quite a ways. I'm scrolling. I'm getting close. All right, here you go, 5/16 drill bits. Now, there's a bunch here, and you're like, which one do I pick? So these are all different sizes, okay? When all else fails, when we pick drills, just pick the one that says jobber, okay? It's kind of your standard boring drill bit, which guess what? That's what we buy, okay? Properties. Now, what number is this guy? It's the 5/16, so it's gonna be number 7, 4525. All right, tool number 7. It has 2 flutes. We feed at 25 inches per minute, did I say? Yep. 25 inches per minute. Spindle speed of 4,000, I think I chose. Yep. 4,000. Retract rate, doesn't matter. You can come up really fast. Okay. I can tell you we're not using a carbide one. High-speed steel. You don't have to change that if you don't want to. All right, there we go. Tool number 7. Drill 5/16 hole. All right. I don't need to worry about the holder or the stock. Now I do need to worry about the cut parameters. Remember, we use this chip break. So it goes down right here, 0.1, pauses, goes down another 0.1, pauses, goes down 0.1, pauses. That allows the chips to break and eject easier. Only I have to do now is go to linking parameters. All right, that's good. Top of stock is 0. How deep do I want to go? All right. In case you don't know, hit depth, and you spin it over, and you're going to pick the bottom. Okay, so it's that deep. All right, we're going absolute, that deep. Now, I'm going to turn this cool tip compensation on, because if I just tell it to go that deep, that's how deep the tip goes. So the hole won't go all the way through it. So I'm going to turn tip compensation on, and see what it does is it knows I have a 118-degree drill bit, which is very standard. It goes out an extra 0.01 inches. So that works really well for us. It'll drill all the way through. It would be a problem if there was anything under it we didn't want to hit. We ain't worried about it, so we're cool. Planes, all G54. Make sure our coolant is definitely on. Hit OK. Boom. We got a drill bit. All right, hit save. Another drill goes right here. 2 more steps and we're done, you guys. Okay, so we're going to pick that hole. We hit OK. All right, tool. We don't have that tool. Right click, create tool. Okay, it automatically goes to drill. Nice. This one is 3/8. So I can maybe. Dang, didn't work. I was hoping that would work. Oh, it's because it's the name. Oh, I typed in 3/8. Boom, there we go. Awesome. I'm going to pick that jobber one. Okay, remember, jobber is our standard boring drill we use. Okay, properties, let's see. It is going to be tool number 8. Okay, it is high-speed steel. Our feed rate, all right, let me check on this guy. The 3/8 one, we're going to go 25s and 4,000. Okay, 25. We can go really fast in this. And our spindle speed is 4,000. Not 400, 4,000. Okay, hit OK. We got that guy in there. We're going to say drill, what was this guy? 3/8 hole. Cut parameters. All right, chip break is good. We need linking parameters. Again, okay, absolute. That's fine. That's fine. I don't know how deep to go, so hit depth. Okay, I'm going to click that circle. That's how deep it's going to go. Negative 0.633. I'm going to turn on tip compensate. It was already turned on from the previous operation. And then I'm going to go to planes. They're good. And make sure my coolant's on. Boom. There we go. Okay, so that's our last drill. All right. Final thing we got to do is we got to do this little fillet around here. All right, so that's going to be a contour. Okay, I am going to pick this edge. Okay, that's where I want to work up to. So pick that edge. I'm going in a clockwise pattern. That's good. Hit OK. All right, what's our tool? Well, we don't have a tool we need. Right click, create tool. All right, we're going to do a ball end mill. Hit next. And then our cutting diameter is going to be 0.25. Okay, I'm not worried about the overall length. You don't really got to worry about that. Finalize properties. This is going to be tool number 9. Okay, now, how fast did I say we're going to go? 5,000, 35, and 50. All right, so spindle speed, 5,000. Feed rate, 35. Plunge rate, we'll go with 50. Retract rate, it can retract really fast. No big deal. It will only have 2 flutes, not that it matters that much. And I can tell you, because I've already pulled these guys out, they're going to be, we're just using cheap high-speed steel ones. Okay, hit finish. Now we have that tool. Our comment will be 1/8 inch fillet. Cut parameters, all right, we leave it to wear. Lead in, lead out. You can have it turned on, doesn't really matter. Linking parameters, all right. Everything's set to absolute, cool, cool. How deep do we go? Well, if I go to 0, I'm at the top of this. I need to go, I'm going to click the button. I need to actually go how deep this is, which isn't very deep. Okay. And then planes are G54, coolant is on, hit OK. And you can see the tip is going to go right there and it's going to make our part or make our fillet. All right. So with that, hey, we're done. If you didn't save, do so. I'm going to pick all these guys. Yeah, I thought I was going to pick all these guys. All right, there we go. And I haven't made my stock yet for a simulation, but I can backplot right now. Okay, there we go. Face it off. Got lots of opti roughing going on. Okay, very efficient. Gets rid of a lot of material really fast. Remember, we are leaving 5/1000ths on it. Okay, that looks like the area mill. Area mill all those. So you're going to start to lose it. And then the drill and the final contour happen really fast. So those just kind of blur. Of course, you can always do a verify. That's fine. But we're getting at almost a 40-minute video. So I will stop here. We'll do another video to do the backside. And then we have another video just to do that guy right there. But, hey, if you did this, you just made a part for a collegiate race car, you guys, and you're in high school. So you should be pretty proud that you guys are working on this kind of cool project right now. All right? Well, there you have it.